Hi, everybody. My name is Boyan. I'm the CTO of SIXT, and it's a great pleasure to be with you today. I want to share with you our platform engineering journey. It's been a path we've been walking for over 10 years now, and I want to highlight how did we get here, what are we focusing currently, and how the near future looks like. Before we continue, I think it's important that we spend a moment on our core business so that you guys understand the environment we operate in. SIXT is one of the leading mobility providers in the world. We serve millions of customers in over 105 countries. We operate over 2,000 locations, and we manage at any point of time over 300,000 vehicles worldwide. That's our core business. And on top of that, we also offer a lot of additional services to our customers. Those include car subscriptions and van and trucks for commercial usage, car sharing, e-hail, and a lot of other things. All of that we make possible by investing heavily in technology. We've been doing that for over 40 years, and by now, over 95% of all software we use at SIXT is built in-house. The heavy lifting is done by our SIXT tech team. That's about 800 extremely bright individuals between product and engineering, and they work in about 100 engineering teams. On a high level, we are structured between product and enabling engineering, and platform engineering is part of our enabling organization. To get here, I guess it's important for you to see what were the first steps that we made 10 years ago. Back in 2015, we had quite a few challenges. We were shipping very slowly, once every 3-4 weeks. And the reasons for that were we had a giant PHP monolith. People were stepping on each other's toes there. We had a very diverse and dispersed technology stack all around, and also quite a few organizational silos. All of those contributing that ideas to production used to take significant time. To solve it, we got together with some of our key engineers, and back in 2015, we made some foundational decisions, many of which are still with us today. Things like which programming languages we want to bet on, how do we move to service-oriented architecture, build versus buy. By far, the most influential decision, which actually set us on our internal developer platform path, was that we wanted to adopt you build it, you own it kind of operating model. We were discussing to go there in order to reduce the hoops and the silos that are on the way for teams to basically create an experience and deliver it to our customers. On the other side, as we were discussing this approach, we saw a number of risks. We were worried that as we move all those responsibilities that come with managing a application lifecycle fully, that will actually slow down our engineering teams even further. And the other challenge that we were also discussing was, well, it is highly possible that our technology stack will diverge even further because teams will be betting on different technologies to solve their daily struggles, and give it enough years, it will be extremely difficult for us to maintain this bouquet of technologies, but also how do we ensure security? How do we ensure compliance? How do we make sure that in the end, everything that we have invested in can be maintained further? So to mitigate some of those risks, an idea came that we could set up a team which solves that for us, where we bet on a number of technologies that solve the problems for all the product engineering teams. And because we're going to get expert in those technologies, we'll be able to automate them and maintain them much easier, thereby also reducing our overall technology fragmentation and also the cognitive load of maintaining many different solutions that kind of do the same thing. So on this slide, I've depicted some of the scribbles we had on the whiteboard back then. But the main outcome is we were hoping that by doing all of that, we would also be able to ship much faster, but also lower our TCO long term. And for us, efficiency is extremely important because any efficiency we gain, especially at that scale, pays back straight into our customers. So this is how we were reasoning back in the day about adopting an internal developer platform journey. Once we set ourselves on this path, we also wanted to make sure the focus of the team is clear. And I think this slide depicts it best. Our fundamental goal is that our product engineering teams continue to spend most of their time on solving customer problems. And for everything else they have to do in order to manage a enterprise production application stack, we want our platform engineering team to create amazing experiences which help them on the way and reduce the day-to-day friction and the day-to-day heavy lifting. So we started building. The approach we took was going for the 80%. We knew even back then when we had a much smaller organization that we would never be able to serve every single flavor of ice cream. And therefore, we really focused on pillars and foundations which we perceived as multipliers for the rest of the engineering organization. Each solution we built had to be batteries included, meaning that it had to just work. Every technology we picked had to be modularized and self-contained because we knew that some bets will pay off while we're going to fail on others, and we need to be able to change major pieces without causing massive explosions. On the other side, we approached the whole topic as 100% automation from day one because with a small team, we had to make sure that we can cover a very large scope. In terms of abstraction and an interface between platform and the rest of the engineering teams, we chose to go API first for two reasons mainly. One, we felt it's a way to integrate which the engineering teams use in their daily job, and therefore it will feel natural instead of going for some niche infrastructure solutions and whatnot, which could be iffy. And two, it was a way for us to compensate for the 20% which might be missing for some teams. So they would be able to build on top of core technologies that have been provided and add those extra missing pieces, which would at that point make that use case much more useful for them. That's as far as the approach goes. When it comes to experience, there was only one way to go about it. It had to feel like magic. It had to feel great, right? It will be used in every single engineering team. So the end user experience was crazy important for us. Each solution had to be self-service. It had to incorporate guardrails, making sure people cannot shoot themselves in the foot while using it. And in terms of appearance, in terms of feeling, what we provide had to really mask the underlying constraints and scalability primitives. It had to feel serverless, and it had to feel like the platform has infinite resources, even though we obviously keep all the product engineering teams, as well as everybody else, accountable for the cost that they produce, the performance of their applications, and everything that comes with their runtime, right? Well, what we wanted to make sure is that, while this is still the case, the underlying complexity remains transparent. Fast forwarding to today, pretty much everything we built is on our internal developer platforms. We reached 100% adoption rate long time ago because, quite frankly, we never looked back. Ever since we started in 2015, anything new that we created, anything we migrated, we made sure that it goes into our target platform, and each team participates. That has been the case for years now. The platform grew. Let me maybe share a few facts with you. Nowadays, we run over 350 Kubernetes nodes, and we usually go for pretty large machines, over 8,000 pods. 2024, we did 112,000 deployments across all our environments. And, contrasting and comparing back to 2015, where we were doing about 2 a month, I think we've come a long way. Our platform engineering teams manage around 1,500 instances, and that doesn't also include all the managed instances we get from AWS. Over 200 database clusters, and we generate over 350,000 web pages. So it's just getting interesting, I guess. Let me give you a bird view of our platform. Few notes from the very beginning. We don't actually have only one IDP. What I'm showing you right now and what I've unpacked for you is our backend platform. Yet there is data platform, ML platform, web and mobile platform, which are different. A lot of layers might be reused, but they also come with additional ones. We will not have time to look into that. That will be a topic for another time. Same goes for our back office platform, which is something that we don't only use for our platform world. It's used also as foundation for most of our back office applications across all our business verticals. There are over 150 applications by now. So in itself, it's also a pretty interesting thing. In terms of the backend platform, all the layers we have, I think, are pretty standard to what you are used to nowadays. We have infrastructure layer that we abstract. We have data stream layer. Data is pretty important for us. It's the fabric that connects all our other platforms, and therefore we invest heavily into that as well. The whole build, deployment, observability stack. Maybe what's very special for us is our platform layer, or what we call our platform layer, because there we go a bit beyond what you would see traditionally when most of the abstractions stop at infrastructure. What we do is we also provide a lot of core capabilities to our applications in the form of platform libraries and obviously the actual runtime implementations. Those things would include service discovery, how actually even service communication happens, event schemas, configuration management, identity and access management. There are a lot of things that we solve centrally, and we let each application use in the form of a platform library. And we're going to have a sneak peek of that in a bit. So that's overall when it comes to our stack high level. I've also included a number of technologies which we still use. Many of those are with us for a pretty long time. For example, Kubernetes and Kafka. It's been a decade, and it's been a very successful cooperation there. Obviously, we've also changed a lot of things on the way, and we keep iterating with the same premises before that. As technology stop working for us, we basically go and replace them. Let me explain you a little bit our experience. If you're an engineer in a product team today, you will be starting your project in Slack. We're big ChatOps fans, by just basically saying what you're trying to do, a small RFC kind of a step where you add some metadata to your application plus describe what you're trying to solve. We have this step because we built a lot of things in parallel, and we want to make sure that we don't reinvent the hot water over and over again. We don't build basically 10 things that do the same thing. And we use it to collect feedback and feed that feedback into the solution at a very early stage before code is written. But past that, once a project is set for creation, pretty much everything from this point on, all the way to being able to ship to prod, is automated. That includes GitHub repositories, associating those things to teams, making sure that permissions are set so that only the team members of that team can commit or can deploy this application. All the build pipelines, all the deployment registries, all the observability stack is prepared for this application. Everything is said and done so that the moment you do your first commit, and if you go to prod, all the insights are there for you. As I mentioned, we do a lot of that in Slack because we're big ChatOps fans, so quite of our teams still are, and a lot of those insights and everything else is wired in there. But we obviously also provide UX experiences. Let me show you a couple of those screens. We have a lot of different views, and we are looking at a very small subset at the moment, but I think it's illustrative for you guys to get an idea in our short slot. Top left, you can see illustrations of our deployment platform. Again, what you can do in Slack, you can also do there. Plus, obviously, a lot more visualizations and insights in one place. I think it's a much better experience, but always it's a taste topic. what's important for us is that it's all built on the same backend. Top right, you can see some of our governance views that basically tracks the adoption of the platform libraries across the different applications. And that's grouped per team. And you can have an application or team view, and then you see how teams are adopting those libraries that are being released usually every quarter. And the system is smart enough that if teams are lagging behind, it will send them notifications. It will, in some cases, do a PR for them, especially if the changes are minimal. So that this process is continuously going. Bottom left, I have for you a small sneak peek of our central configuration service where each application can register feature flags and configuration options that can be changed on the fly. It comes with audit logs and anything that you can imagine needed for running production applications at scale. Same goes on the right side, bottom right, for our event views. As I mentioned, data is very important for us, and PubSub is a pattern that we use heavily across pretty much every single application we have, and therefore we've invested a lot to be able to control and view and manage anything that is being published. We can trace the life cycle of every single event, where it came from, what kind of metadata is in that, the event schema itself, as well as who is subscribing to this event and how this data is morphed afterwards. This is pretty important, as I mentioned, because data and everything we do afterwards with it is pretty crucial for our core business. That's when it comes to, front ends. We are not going to have time to go too much into more details. I think what's important to mention is that a platform is never done, right? Never finished. We keep iterating, we keep introducing new technologies. Let me show you a couple of those. Something that we just released several months ago is a concept that we call internally overlay environments. What this does is it allows teams to basically deploy different versions of the same application in complete isolation and test that end to end while still relying on dependencies that they might have in a pre-prod environment and the data behind them and the infrastructure behind them. What this helps with is when we test very large end-to-end user flows that combine a lot of different systems and therefore a lot of different teams, this unblocks them to test in parallel instead of having to agree on versions and multiple people testing multiple things. Extremely helpful. The thing that makes also every CTO happy is that it's a very efficient solution. We minimize costs massively because we don't have to keep rebuilding huge infrastructure environments for short-lived tests. And the user experience is also pretty cool. It's something that our teams have already adopted in their daily use cases, and things like that are extremely helpful. We are also working on quite a few cool things. I will go very quickly and share some of that. Some of it probably is also relevant for you guys. One is global MCP support. MCP is a protocol that is on the rise at the moment, and while we cannot predict the future and how well this is going to age, what we know right now is that as many companies out there, we are building dozens of agentic workflows internally, and we need to power them somehow. MCP right now seems to be the way. And instead of going and changing every single application we have to support SAC and MCP natively, what we could do and what we are doing at the moment is just building a gateway, which basically abstracts our whole internal world in a seamless manner and pretty much can turn any application we have and its interface, which in our world is gRPC, into a MCP tools to be used straight into our agents for the actions that they need to take, which is incredibly powerful if you think about it, because you can overload it with all the security and all the compliance topics that you care about and that we care about in our world. So this is one thing, and I think it's a great example to demonstrate, the power that you get if you actually standardize and if you're able to keep your stack together. Another area that we are heavily investing in is the next iteration of our Slack experience, which is basically going into a more agentic platform assistant experience. And just to be clear here, what we are not trying to do is replace our deterministic commands, which are actually pretty cool and work pretty well with predefined outputs, which have been optimized over time. We're not trying to replace that. I think that would be a massive waste of time, and the bloat itself is not something that we like taste-wise. But what we're trying to do instead is we're trying to combine a bunch of sources and try to compress the amount of time it takes today when things are not maybe going great, not full outage, where I think usually things are pretty clear for an application, but more something is iffy, something is not going well, and then teams and engineers spend quite some time to look at different dashboards, compare and contrast, check if it's an environmental thing, if it's a new version thing, if it's a configuration thing, look at monitoring system, etc. What we're trying to do is combine all of those sources and try to lead them on this debugging journey in a much more efficient manner. That's one. Two, we're also trying to move a lot of the experiences, especially with our overlay environments and everything else together, straight into the IDEs, where we believe it will be 10x experience, and then people having to switch context between Slack and IDE and UX. Remains to be proven, but this is something we're pretty optimistic about. Last but not least, a topic that is extremely near and dear to our hearts, goes beyond our backend platform and what we've discussed so far, but it's extremely cool, and I can't not highlight that because we're so excited about it. We started a few months ago a project which goal is to get us from design to prod in minimal time. And that what you guys are seeing right now is our mobile world. And because we've invested heavily in the past years in standardization, in having consistent mobile architecture for iOS, for Android, we've invested also years in building up our design system, which is the interface between our engineering world and our design. We are able to now focus on one more layer, a spatial positioning, generally I have to find a name for that, but one extra layer, which allowed us to already have the first fully generated screens with minimal manual intervention already in production. And that's huge for multiple reasons. One, business-wise, it's a massive increment because basically it allows you to pack a day and a half work into 10-15 minutes. But two, it also allows our teams to go away from spending too much time in finding pixel perfect solutions themselves and looking back between designs and components and architecture, and really focus on the complicated business logic, while everything else we are able to self-generate. And again, I think it's just an example which shows the power of standardization. If you go that way, it seems to be working pretty well for us anyway. And we are incredibly excited about this particular project because we can replicate that experience for web, for backend as well in certain cases. And those are some of the things we're doing at the moment. Thank you for listening. I hope it wasn't too boring, and it's been a pleasure being with you. Bye.